Have you ever heard the expression, I wouldn't touch that with a 10-foot pole? Well, that came from the bubonic plague. Back in the 1300s, also called the Black Death, 40 million people died of this plague. It was our first documented pandemic, which means worldwide epidemic. These were our dark times when this gram-negative rod, known as Yersinia pestis, was transmitted or vectored. We call vector something that transmits. Is vectored by fleas that hitchhike on rats. What Yersinia does is it circulates in the blood and causes hemorrhages or internal bleeding, especially in the lymph nodes. People that suffered from this disease had buboes or purple splotches just under the skin where the lymph nodes were. Look at that bacillus. Yersinia in its worst times was spread through respiration droplets when people would cough and sneeze. This is called pneumonic plague, and the mortality rates for this were 100%. And this happened in some of the cities in Europe when people are living close together. It just spread like a fire. Another dark time in history, smallpox. But there was a bright moment when Edward Jenner in the 1700s, he noticed that milkmaids had a mild form of smallpox called cowpox. And interesting, these milkmaids did not get smallpox. So what Jenner did was something we can't do today. He experimented on children. He took fluids from lesions from these milkmaids, and you can see in this photograph that one woman, she's holding a handkerchief across her wrist, and that's where the fluid was taken from, and then it was injected in children. And so here we have, back in the 1700s, one of the first documented cases of the use of a vaccine. Germ theory, 1860s. This is when we finally broke out of those dark ages and we started to appreciate science. Robert Koch, and Louis Pasteur, they are responsible for the germ theory. Before their work, people believed that there was poisonous vapors or curses brought down upon people. They didn't understand that there were organisms out there causing problems. Louis Pasteur, the first scientist to show that diseases were spread from other infections. He also discovered something called pasteurization, or heat flashing. And that's when most, but not all, the bacteria in a culture are destroyed. We use pasteurization because we don't want to sterilize. Sterilize kills the bacteria but reduces the flavor and the nutritive value of beverages and foods. So some bacteria are going to survive, and that means pasteurized products have a limited shelf life. We've got to consume them before they get too ripe. There's a famous mysterious painting of Louis Pasteur and a woman that's seen through a doorway. All right, let's look at his vaccine. He found that if he took blood from infected chickens and extracted it and pasteurized it over a flame, well, something happened. He took this pasteurized cholera blood and injected it in live chickens, and the chickens didn't die. And that makes sense, right? Because he's heat flashed the cholera, so something's different about the cholera. But the neat thing is, then he took deadly cholera from an infected chicken and injected it into one of the chickens that had been treated with the pasteurized blood, and the chicken did not die. So from his work, he showed that if we alter an organism, such as by pasteurizing it, it provides some protection against disease. He called them vaccines. The word vacca comes from cows, and it's based on the cowpox work of Jenner's. So vacca is a Latin word meaning cow. Robert Koch same period as Pasteur, studied etiology. Etiology means the cause of a disease. He worked with Bacillus anthracis. This bacteria was like a wildfire. It was a type of plague that was spreading through livestock and human populations, causing internal hemorrhaging. And when blood congeals and darkens, it appears almost black. Anthracis means coal. The endospores of anthrax can lie dormant for up to 30 years. And so a lot of cattle were burned rather than just burying them. Here's his experiment, really quite slick and quite simple. He took blood from animals that had died of anthrax, and he looked at their blood, and there were rod-shaped factors in the blood that didn't belong there. Now we call these bacillus today. Back then he just called them rod-shaped factors. Then he injected these rod-shaped factors into healthy mice. Soon the mice died of anthrax, which you would expect, right? But what was cool is he took the blood from these and he found the same rod-shaped factors. Now it doesn't take a genius to figure this out, but think of this. This is several hundred years ago when people were still thinking that the curses and poisonous vapors were causing things. So his postulate or theory was that each type of microbe causes a specific disease. It wasn't like one evil factor or some poisonous vapor that was causing these different diseases. Today, Bacillus anthracis is still around as a bioterrorism agent because it spreads through the lymphatic system and it cannot be destroyed by antibiotics in its later stages. If you touch it, breathe it, or ingest it, it can kill you any of those three ways. Semmelweis. This is a good story. He showed that maternity patients recovered quickly if doctors washed their hands before the procedure. Now, back then, doctors would just wear their street clothing, and they might have parts of intestines from their last surgery still hanging on their clothes. So with Semmelweis' discovery, we took a giant step in antiseptic procedures. Even today, hand washing is still a very powerful method to reduce bacterial infections. Joseph Lister, you might have heard about this guy. He invented an antiseptic mixture sprayed on patients before operations. See, the way it was is people would have a procedure done, they'd be fine, and then 2 weeks later they'd die of an infection. But with Lister's technique, it coated the skin and destroyed a lot of the Staphylococcus aureus and prevented this bacteria from entering wounds. Today he's famous for, you guessed it, Listerine. I don't know if I'd gargle with it, but it sure is a potent antiseptic. Fleming, Alexander Fleming, known for his work with Staphylococcus. He was growing them in bacterial plates, and he noticed that no bacteria grew near this slimy piece of mold named penicillium. From this, he invented an antibiotic that has saved millions of lives. Until recently, many of the bacteria have produced a penicillinase, a type of enzyme that breaks down penicillin. So, unfortunately, this drug is not as effective as it once was. There are some beneficial bacteria. In fact, many, many beneficial bacteria. So they're not all evil, like I'm sort of indicating in my lecture. Staphylococcus aureus, okay, maybe it does some bad things, such as when we break our skin and it causes a staph infection. But it's on the surface of our skin, protecting us against fungal infections. So you don't want to scrub too aggressively in that shower, because you want to leave a small film of Staphylococcus aureus there to protect you against ringworm and athlete's foot and crotch rot. There's worse names than that are out there waiting for us. Nitrobacter. This is a neat recycling bacteria. Think about all the dead things that have ever died. We'd have to swim just to get to school. All the dead earthworms, all the dead branches, all the dead skunks and toads. But fortunately, Nitrobacter and some other bacteria convert nitrates from proteins of dead things into an elemental nitrogen so that plants can absorb them, and then plants grow and produce proteins. And the cycle continues. Escherichia coli, here's another one that is good but also bad. It can cause serious intestinal problems and death. But in the colon, it makes vitamin K. It's one of the few good sources of vitamin K, and it also expels cholesterol from the body. We take care of these guys by feeding them lots of fibrous sorts of foods like oatmeal. Lactobacillus acidophilus. This one resides in the vagina and helps maintain an acidic environment. And it protects a woman from candida and other types of fungal yeast infections. There are many other good bacteria out there helping us survive.
In summary, we had that dark period, the Black Death or bubonic plague, which was a worldwide epidemic, which we call a pandemic. 1300s were the most severe cases, where 40 million people died of plague. Yersinia pestis was responsible. It's a gram-negative, rod-shaped bacillus that caused the plague. Fleas were vectors. One of the symptoms was hemorrhages in the lymph nodes and caused buboes or purple splotches in these nodes. Pneumonic plague was the most severe form, spread from human to human by respiratory droplets, 100% mortality. Smallpox epidemic. Jenner worked in the 1700s. Observed milkmaids had cowpox, which is a mild form of smallpox, and they were immune to smallpox. So he injected fluids from smallpox lesions, and so we have early work on vaccines. Germ theory of disease. Prior to this time, people thought evil forces or poisonous vapors caused disease. But Pasteur was the first to show that diseases spread from other sources. He flashed heated products and increased their shelf life, but he didn't sterilize them, which affects the flavor and nutritional value. Vaccines for cholera is where he heated a cholera fluid over a candle and injected it into chickens, and they became immune to cholera. He found that an altered form of the organism provided protection, and he coined the word vaca, meaning cow, based on Jenner's work. Koch, same time period as Pasteur, studied the etiology of anthrax. Bacillus anthracis is the organism, affects humans and cattle, causes hemorrhaging. Anthrax means black. Endospores lie dormant for 30 years, so this is a dangerous and widespread, long-lasting pathogen. Koch extracted blood from an animal that died of anthrax, saw rod-shaped bacteria. He didn't know the word bacillus back then. Injected this blood into healthy mice, and the mice died. His theory was one disease caused by one microbe, and that it's not one evil microbe causing lots of diseases. Bacillus anthracis is still around. It's used in bioterrorism, spreads through the lymphatic system, and there's no antidote. Semmelweis, same time period. Maternity patients recovered quickly when doctors washed their hands. Joseph Lister, antiseptic. He sprayed patients before operations and decreased infection and increased post-operative survival. Our skin is coated with Staph aureus. Fleming, he worked with Staphylococcus, and he noticed that none of this bacteria would grow around a type of penicillin fungus. And it's worked really well until recently bacteria have evolved penicillinase. Beneficial bacteria include Staph aureus. This is a bad guy and a good guy, right? Because it grows on the skin, it competes with fungi, but it may cause skin infections when we get cut. Nitrobacter is a recycling bacteria. In soil, it converts the proteins in dead matter into nitrates that plants use. E. coli, one of our colon members, is a regular source of vitamin K, which we really need, and it expels excess cholesterol from the body. And finally, lactobacillus in the vagina creates an acidic environment that reduces the fungal growth and reduces yeast infections. Wow.